All right, this is a video for geometry in our right triangle trigonometry unit on angles of elevation and depression. And we'll start off with a couple introductory explanations and then do a few solved examples. So just think of elevation as being upwards and depression being downwards. And we just need to be able to label some of these angles here. So an angle of elevation is an angle between the horizontal upward to something that's above you. So relative to this person doing the viewing right here, looking at that eagle, that person would be looking upwards at an angle of elevation relative to the horizontal. And that person would then be looking downwards at an angle of depression to look at the fish. Okay, so this is an angle of depression, looking downwards, and angle of elevation looking upwards. Important thing to keep in mind, we don't really care about this total angle right there, okay? When we're working with these sorts of problems, we just care about the angles relative to the horizontal, right? So we don't care about the sum of those two angles. We don't care about that total angle. All right, so let's do a quick example problem here. Real quick, it's asking for what type of angle, and we have 4 different angles listed there. Maybe pause this video, try to answer it on your own. Remember, angles are always relative to a horizontal, and they're also relative to the person or item or animal or object doing the viewing. Okay, so for angle 1, that's going to be an angle of depression. That bird is looking downwards at the balloon relative to the horizontal. Angle 2 is going to be an angle of elevation. I hope you can see that angles 1 and angles 2 will be congruent angles, okay? They're actually alternate interior angles in geometry vocabulary. They're congruent angles, but 2 is an angle of elevation and 1's an angle of depression. Person in the balloon is looking downwards at the base of the mountain at angle 3, so that would be an angle of depression. And somebody down at the base of the mountain is looking upwards at the balloon. Angle 4 would be an angle of elevation. Okay, so just a little bit of vocabulary and terminology there. Let's actually apply it, okay? So this is, if you're understanding right triangle trigonometry, there's nothing new with this problem. It's just applying what we've done. And in this case, we're gonna find the height of a tree, okay? So here you can see a 2-meter tall person, or maybe 2-meter height to their eye level, right, is standing 53 meters away from a tree. And then angle of elevation is 14.3 degrees upwards to the top of the tree. Let's assume the tree is a vertical tree, so we can assume we're dealing with right angles in these triangles, okay? Now, what we're going to do first is deal with the just this triangle. And then what we'll need to do is add on 2 meters of the height later. Okay, so let's just deal with the triangle first. I hope you can see we can label HOA, hypotenuse, opposite, and adjacent. And keeping in mind the opposite just goes down to 2 meters above the ground on that tree. So it looks like we're going to be using tangent. We can write out that the tangent of 14.3 degrees is equal to our unknown partial height of the tree divided by 53, the adjacent side. Let me multiply both sides by 53, and we can say that 53 times the tangent of 14.3 is equal to x. I'm actually going to try to do everything in my calculator at the very end. And so I hope you can see that my full height is 53 times the tangent of 14.3 plus 2 meters. Okay, we're adding on the 2 meters height, 2-meter eye height of the person doing the sighting. So that would be the full height of my tree. That would be my answer right there. And we can go to our calculator and determine that number. So I get a full height of 27.02 meters. I'm going to double check that. I saw something glitchy on my calculator, so I just want to check it. think that's wrong. I think what I did is I multiplied by 2 instead of adding 2. So let me check it one more time. 14.3, let's get the tangent of that. And then I'm going to multiply that by 53. And then I'm going to add 2 on at the end. So I did make a mistake here, and that's okay. The correct answer is 15.51 meters. I think I had multiplied by 2 instead of adding 2. All right, so that would be the height of my tree, about a 50-foot tall tree, so a pretty tall tree. This next example that we're going to do involves a plane coming in for a landing at an airport. And we can see that the plane has an angle of depression of 3 degrees as it's viewing the airport from the cockpit. And presumably the airport would have an angle of elevation of also 3 degrees looking at the plane above the ground. We're being told that the airport is 1,007 feet above sea level and the plane begins the descent at 2,714 feet above sea level. So what that means, let me make a little bit larger picture here. If this is 2714 right here, nope, the plane's at 2714. So we're at 2714 here, and we're at 1,007 here. What really matters is the difference. So the plane is 1,707 feet above the ground. Okay, so let's fill in that triangle right there. And we're determining the distance from the airport. Now this is a little bit unclear in the way this question is asked, and if this was on a test or a quiz or something higher stakes, you would really want to be clear, are we looking for this distance, the actual distance the plane will travel through space, or are we looking for the horizontal distance? Okay, and I think both would be valid answers here for this problem. I'm going to just make the call and say let's look for the horizontal distance, but we could certainly find the hypotenuse, the diagonal distance as well. So this is what we're looking for. We're going to call this x. Let's go ahead and label HOA relative to our angle. Remember that this is 3 degrees as well. Those are alternate interior angles and therefore congruent. So this hypotenuse is h, the 1707 is my opposite, and x is my adjacent. So it looks like I don't care about my hypotenuse at this point. I don't know it, I don't want to know it, I just care about my opposite and adjacent sides of the triangle. So I'm going to choose to use tangent here. Tangent is the ratio of the opposite to the adjacent sides. So I can say that the tangent of 3 degrees is equal to that 1707 divided by our unknown x. Okay, we'll multiply both sides by x to get it up and out of the denominator. And then what we need to do is divide both sides by the tangent of 3 to isolate for x. And again, I suggest you do all this algebra before you go to your calculator, and then just go to your calculator once at the very end so you don't have to do any rounding, you don't have to round to the very, very final answer. So that looks like what we need to get into our calculator, and let's go ahead and do it. 1707 divided by the tangent of 3, and I get x is equal to 32,571.50. So it would be 32,571.50 feet is the horizontal distance that the plane needs to travel from its current location to the actual airport. All right, we got through it. Right triangle trigonometry, angles of elevation and depression, and that's a great place to stop right there.